Imagine a world where the sun dictates your entire day. When it's set, darkness would fall like a thick, heavy blanket over everything. For thousands of years, this was reality for all of humanity. People relied on fire to push back the night. They used flickering torches, smoky oil lamps, and candles made from animal fat or beeswax. These light sources were not just dim and unreliable, they were also quite dangerous. An open flame could easily start a fire, and the smoke they produced filled homes, making the air difficult to breathe and staining walls with soot. It was a constant, risky chore to keep the darkness at bay. Life was fundamentally limited by the daylight hours. When the sun went down, most activities simply had to stop. Reading a book was a strain on the eyes, possible only if you were very close to a weak, sputtering flame. Detailed work, like sewing or crafting, became nearly impossible. Social gatherings were often cut short, and travel at night was a perilous adventure into the unknown. The world shrank every evening, and the long nights, especially in winter, were periods of inactivity and waiting. People yearned for a better way to light up their lives, a way that was safer, brighter, and more dependable than fire. The need for a new kind of light was not just about convenience, it was about safety and progress. Cities were treacherous places after sunset. Streets were unlit, making it easy for people to trip and fall or become victims of crime hiding in the shadows. Watchmen patrolled with lanterns, but their small pools of light did little to illuminate the vast, dark urban landscape. Businesses had to close their doors early, limiting economic activity. The dream of a clean, bright, and easily controlled light source was a powerful one. It was a dream of extending the day and unlocking human potential. This universal challenge inspired countless thinkers and inventors. They knew that mastering light would change the world in incredible ways. It would mean children could study after dark, workers could be more productive, and cities could become vibrant, active places 24 hours a day. The quest was on to find a way to create light without the danger and mess of fire. It was a scientific adventure that would take decades of trial and error, building on small discoveries and brilliant insights. The journey to illuminate our world was just beginning, starting not with a flash, but with a simple spark of curiosity. The journey toward electric light began not with a bulb, but with a battery. Consider this. You can't have a light bulb without a steady source of electricity. Around the year 1800, an Italian scientist named Alessandro Volta made a fantastic discovery. He stacked discs of copper and zinc, separated by cloth soaked in salt water. This invention, the voltaic pile, was the world's first electric battery. It could produce a reliable, continuous electric current. Volta had opened the door, providing the power source that future inventors would need to create light from electricity. His work was the foundational step upon which all other progress would be built. Just a few years later, an English chemist named Humphrey Davy took that new electrical power and did something spectacular with it. In 1802, he connected Volta's powerful battery to two charcoal rods. When he touched the tips of the rods together, and then pulled them slightly apart, a brilliant arc of light leaped across the gap. He had invented the electric arc lamp. It was incredibly bright, far too bright and intense for use in a home, but it proved that electricity could be used to create powerful light. Arc lamps were later used to light up public squares and lighthouses, showing the world the potential of electric illumination on a grand scale. The next big idea was to make light by heating something up until it glowed. This is called incandescence. The challenge was finding a material that could get white hot without burning up or melting instantly. In 1840, a British scientist named Warren de la Rue tried an experiment. He placed a coiled piece of platinum wire inside a glass tube and sucked out the air to create a vacuum. When he passed electricity through the platinum, it glowed brightly. Platinum was a great choice, because it has a very high melting point, but it was far too expensive to be a practical solution for everyone. De la Rue's work, however, showed that a long-lasting light bulb was scientifically possible. These early pioneers, and many others, were like members of a relay team passing a baton through history. Volta provided the power, Davy showed that electricity could make a dazzling light, and de la Rue demonstrated the principle of a glowing filament in a vacuum. Each discovery, even if it wasn't a complete solution, added a crucial piece to the puzzle. The dream of a simple, affordable electric light for every home was getting closer. The next challenge was the biggest one yet, finding the perfect, inexpensive material that could glow for hundreds of hours without breaking. The race was on. The 1870s became a hotbed of invention, with scientists all over the world racing to find the perfect filament, the tiny wire inside the bulb that glows. In England, a chemist named Joseph Swan was making significant progress. He had been experimenting with carbonized paper filaments and, by 1878, had developed a long-lasting light bulb. He even demonstrated it publicly and began installing it in homes in England. Swan's work was a major leap forward, proving that a practical incandescent bulb was within reach. He tackled the problem of the filament head-on and came very close to the final solution that would light up the world. Meanwhile, across the Atlantic Ocean in the United States, Thomas Alva Edison and his team of researchers at their Menlo Park laboratory were also working relentlessly on the same problem. Edison knew that a successful bulb needed more than just a good filament. It needed to be part of a complete system. He tested thousands of different materials for his filament, from coconut fiber to beard hair, searching for one that was durable and affordable. In 1879, he finally found success with a piece of carbonized bamboo fiber, which glowed steadily for over 1,200 hours. This was a huge breakthrough in longevity. But Edison's true genius was not just inventing a better light bulb. It was in creating the entire infrastructure needed to make electric lighting practical for everyone. Think about it. A light bulb is useless without a socket to screw it into, wires to bring it power, and a power plant to generate the electricity in the first place. Edison and his team designed and patented all of it: generators, fuses, switches, and meters. He envisioned a whole network that could safely deliver electricity from a central station directly into people's homes and businesses, making electric light as easy to use as turning a switch. This complete system approach is what set Edison apart and allowed him to bring electric light to the masses. In 1882, he launched his first commercial power station on Pearl Street in New York City, powering the lights in an entire neighborhood. It was a historic moment. For the first time, safe, reliable, and relatively affordable electric light was available on a large scale. While many brilliant minds contributed to the invention of the light bulb, it was Edison's focus on creating a practical and complete system that truly sparked the electrical revolution and began to illuminate the modern world. Edison's carbon filament bulb was revolutionary, but science never stands still. Even after its invention, engineers and scientists continued to search for ways to make light bulbs even better, brighter, and more efficient. The next major breakthrough came in the early 1900s with the use of a new material for the filament: tungsten. Tungsten has an incredibly high melting point, even higher than platinum, which means it can get much hotter and glow much more brightly without vaporizing. Early tungsten filaments were fragile, but by 1910, a process was developed to create strong, ductile tungsten wire, making it the standard for incandescent bulbs for nearly a century. The innovation didn't stop there. Scientists discovered that the tungsten filament would last even longer if the bulb wasn't a vacuum. They tried filling the bulb with an inert, non-reactive gas, like argon or nitrogen. This gas created pressure inside the bulb that prevented the tiny particles of the tungsten filament from boiling off as it got hot. This simple change dramatically increased the lifespan and efficiency of the incandescent bulb. These gas-filled tungsten filament bulbs became the familiar light source that lit up homes, schools, and offices for most of the 20th century, a testament to continuous improvement. A completely different kind of lighting technology was also being developed: the fluorescent lamp. Instead of heating a filament, a fluorescent lamp works by passing an electric current through a gas-filled tube. This creates invisible ultraviolet light. The inside of the tube is coated with a phosphor material, and when the ultraviolet light hits this coating, the phosphor glows, producing visible light. First introduced to the public at the 1939 New York World's Fair, fluorescent lights were far more energy efficient than incandescent bulbs and lasted much longer, making them perfect for lighting large spaces like factories, offices, and schools. Today, we are in the middle of another lighting revolution, perhaps the biggest one since Edison: the rise of the LED, or light-emitting diode. LEDs are tiny, solid-state electronic components that produce light when electricity passes through them. They are incredibly energy efficient, converting most of the electricity directly into light instead of wasting it as heat. They can last for tens of thousands of hours and can be made to produce any color of light. From the first spark in Davy's lab to the smart, color-changing LED bulbs in our homes today, The journey of the electric bulb is a shining example of how science keeps building on itself to make our world a brighter place. The spread of the electric light bulb changed human civilization more profoundly than almost any other invention. Its most immediate effect was on the rhythm of daily life. Suddenly, the day no longer ended at sunset. People could read, socialize, and work into the late hours of the evening in bright, clear light. For families, this meant more time together, and for students, it meant the ability to study and do homework at night, opening up educational opportunities for millions. The simple act of flipping a switch extended the useful hours in a day, fundamentally altering how we live, learn, and interact with one another. The impact on work and industry was equally transformative. Factories, which previously had to rely on sunlight from windows or the fire risk of gas lamps, could now operate safely around the clock. This led to the creation of night shifts, boosting production and fueling economic growth. Office workers could continue their tasks long after dark, and businesses could stay open later to serve customers. The electric light bulb didn't just illuminate workplaces, it powered a new, more productive and dynamic economy that could function 24 hours a day, 7 days a week, fundamentally reshaping the world of commerce. Beyond our homes and workplaces, electric light made our communities safer. Brightly lit streets and public spaces deterred crime and reduced accidents, making cities more livable and welcoming at night. People felt more secure walking outside after dark, which encouraged the growth of a vibrant nightlife with theaters, restaurants, and social events. The bulb also became a critical tool in science and medicine, allowing for precise, detailed work in laboratories and operating rooms at any hour. From intricate surgeries to late-night scientific research, progress was no longer held back by the setting of the sun. It was a new era of safety and discovery. The story of the light bulb teaches us a powerful lesson about innovation. It wasn't the creation of one single person, but the result of many minds working over many decades, each building on the successes and failures of those who came before. From Volta's battery to Edison's system to the modern LED, it is a story of teamwork, persistence, and a shared desire to solve a problem and improve people's lives. Today, with smart bulbs we can control with our voices, the bulb continues to evolve. It remains a shining symbol of human ingenuity, and a reminder that even the biggest world-changing ideas often begin with a single, tiny spark.